The Doppler effect. Sound is a vibration that travels through the air. No matter how quickly the car is moving, the sound leaves the vehicle and travels through the air at its usual wave speed. In other words, if the car is moving quickly, it is catching up to the sound waves it is producing. This demonstrates that the wavelength is decreased by the amount of distance a car travels in a single trip. Who discovered the Doppler effect? Christian Andreas Doppler, an Austrian mathematician and physicist, is most known for his breakthrough idea of the Doppler effect, which has had a profound impact on many fields of different branches of science, including medicine. His creative work created the basis for the present ultrasound, and his ideas continue to inspire scientific breakthroughs more than a century after his death. Doppler may probably be awarded the title of Homo Universalis due to his extensive understanding of physics, mathematics, and astronomy, as well as his tireless pursuit of new concepts and brilliant intellect. What is the Doppler effect in physics terms? The Doppler effect is the shift in wave frequency caused by the relative velocity of the wave source and its observer. Example of Doppler effect. The waves collide more frequently when the wavelength is shorter, as can be seen in the figure to the right. When the waves are further apart, as at the left of the figure, the waves arrive less often. A higher frequency corresponds to a higher note or pitch. Reduced frequency translates into a lower pitch or sound. Likewise, doubling the frequency results in having the wavelength. After the automobile is approaching, the pitch sounds high, and when it passes, it sounds low. How is the Doppler effect used in medical science? Although ultrasounds may produce pictures of inside body structures, they cannot detect blood flow. When moving things, such as blood cells, create sound waves, the Doppler effect can record them. The Doppler effect is utilized in medical science to determine the location of a pulse and if a part of the body is receiving blood. Diagnosis through the Doppler effect. Clots in the blood. Blood or other fluids might accumulate in your legs if the valves in your leg veins do not operate properly. Venous insufficiency. Congenital heart disease and heart valve defects. An artery that is clogged, arterial occlusion. Reduced blood circulation to the legs, peripheral artery disease. Vein swelling, aneurysms. An arterial weakening, such as in your neck, carotid artery stenosis. Doppler effect model. Regular. A stable sound produces sound waves with a constant frequency, and the ripple moves away from the source at the same rate. The spacing between wavefronts is specified as the wavelength. All observers would hear the same frequencies, which is equal to the real frequency of the source, where f equals f0. Doppler effect model. Breaking the sound barrier. The source is now moving across the medium at the speed of sound. At this point, all wavefronts in front of the source have converged. Because of this, an observer in front of the source doesn't hear anything until the source arrives, whereas an observer behind the source hears a lower frequency. Doppler effect model. Supersonic. The sound source is now traveling at 1.4 c, which is faster than the medium speed of sound. Because it moves faster than the sound waves it creates, the source moves ahead of the wavefront. The sound will not be heard by a stationary observer until the source has passed by. As a result, someone in front of the source will hear nothing, whereas someone behind the source will hear a lower frequency. The Doppler effect's most common limitation is that it is only significant when the velocities of the source of the sound and the observer are substantially less than the velocity of sound. In conclusion, the concept of the Doppler effect has benefited many areas of research, such as medicine, and it will continue to impact many fields in the future.